Actually, I'm going to turn it over to John Skinner first at the University of Tennessee to welcome everyone to this webinar series. John, take it away.
Hi. Hello, everybody. I'm very pleased to see it's so widely represented across the United States and in many other countries. I'm glad you have an interest in this topic. You have tuned in to a webinar on ensuring crop pollination in U.S. specialty crops. And this is basically, most of the participants in this are also involved in the ICP program, which is integrated crop pollination. It's an important aspect of way of looking at pollination and how much we need our pollinators. This is a series of 6 webinars. We are in the second one, and it's going to be exciting, just like the rest of them. We're going to be learning all about blueberries today, and this is a treat because you've got some of the best experts in the country on these different topics. Especially, hi Rufus, how you doing?
Good. How are you, John?
Good to see you. And Katharina, would you please introduce our speaker for today? And thank you very much again, everyone, for listening in.
Yeah, it's great to see such a good turnout, and I'm really excited. We're all really excited that Rufus Isaacs is here to present on blueberries and their pollinators today. Rufus is a professor and extension specialist in the Department of Entomology at Michigan State University in the United States. And he's been studying blueberries for the last 20 years. So he's got a wealth of knowledge. He works a lot directly with growers and also with researchers within the research community. And his research has really focused on both pollination and pest management in small fruit in general, but again, he's going to be focusing on pollination in blueberry today. Emily May, who's a colleague of mine from the Xerces Society and who was a grad student in Rufus's lab, just put his university website in the chat box. So if you want to check out his website, go there. You can ask questions for Rufus, as has been stated already, using the Q&A box throughout this talk. Rufus will be stopping at least one time in the middle of the talk to answer any questions that come up. So just pop in questions as they come up in his talk. Also, again, as a reminder for those using chat, if you want to join the entire conversation, make sure you select everyone in that to field of the chat box so that everyone can see and hear and participate in that conversation. Now, while I'm about to turn it over to Rufus to start his presentation, before I do that, Mark Locklear is going to put out a little poll. It's just got a couple of questions so that we can learn where you're located and what your primary role is related to pollination and crop pollinators. And one other thing I want to mention before passing it over to Rufus is that for those of you interested in certified Crop Advisor credit, you can get 1 crop management credit today. We'll post a link at the end of the webinar in the chat box for those who want to put in their name and their CCA number to get credit. So as soon as people are finished with the polls, we'll pass it on to Rufus. And Mark, maybe can you let us know when the poll is closed? So that
sure. We've got, there's about 70 of 120 that have voted now, so I'll just continue to leave that up. And in fact, if Rufus wants to go ahead and share his screen and get going there, I can leave the poll up and then I can end it just before he starts.
All right, are you seeing the slides there?
We are, yeah, it looks good. In fact, let's just take another 20 seconds or so to give folks a chance to finish up the poll.
And I'm sorry we don't have an option for the Northeast. I just noticed that in the chat.
That's true. We had Northwest, but we did not have
Sorry, Sonia.
Northeast. Okay, I think we're good to go. We've got about 90, almost 100 folks that have voted on the poll, so I think you're okay to go ahead and get started.
All right, very good. Well, thanks everyone for joining today. Good morning, good afternoon, good evening, wherever you are. I see people from all kinds of parts of this country and around the world, so that's excellent. Before I get started, I've just got to get organized here because I need to be able to see my slides, and they're now over on my left side. Mark, is there a way I can move them back to my original screen? Or?
I don't think so. If they're your notes that are part of your presentation.
Just the slides that I'm presenting.
Well, yeah, if you can move them. I don't know if you can move the window, but if you can, if you're not able to drag it over to where you'd like, then
okay,
maybe
all right,
not.
Well, we'll do it. We'll make it work. You just get to see the side of my head while I look across the office here. So yeah, so we're talking today about pollinating highbush blueberries. The focus will be on the role of bees in highbush blueberry production. And so I've got my email address there on the front slide. If you're interested in sending a message afterwards, please do. And I wanted to highlight right at the beginning that this is a team effort. I'm presenting on this today, but within this integrated crop pollination project, there are 4 universities collaborating, one in British Columbia with Elizabeth Ellie's group, Sujaya Rao's team at Oregon State University, my group here at Michigan State, and then Jamie Ellis's group at the University of Florida. So just wanted to acknowledge the teamwork that's gone into this project. All right, let's see if I can figure out how to go to the next slide. There we go. Okay, so this blueberry part is also part of a larger project, and just wanted to also let everyone know that there's more webinars coming up later this month and into next month on integrated crop pollination across the different systems. So you'll be able to hear from some of the folks in this photograph. We've got a lot of organizations represented, and then also we have an advisory board that's been helping to keep us on track. So I wanted to thank them if any of those folks are on the call today. So the focus is on blueberry pollination. This photograph hopefully makes the point very clearly. The one on your left is a set of flowers that were excluded, or bees were excluded from them during bloom with some very light mesh. And the one on the right, bees were allowed to visit. So that pollination process is critical for getting more of the flowers to turn into fruit, for getting those fruit to have fertilized seeds, which make the fruit larger, they ripen more quickly, and the grower gets larger berries to be able to harvest. So it just emphasizes the importance of pollination in this photograph. In our project that I'll be alluding to a number of times during this call, we're focusing on trying to integrate honeybees, wild bees, where they fit, where we can build their numbers, alternative managed bees, and you'll hear some of that today and then in the other webinars. And then thinking about how farmers can make their farms more suitable for these pollinators to survive and persist and do the work that you want them to do. Just to go back to your school lessons, pollination, as I'm sure you know, is the movement of pollen from the male to the female parts of the flower, and the deposition of that causes the pollination to happen. And in blueberries, it's relevant to keep in mind that you can have self-pollination where the pollen moves from the same flower or same plant to the reproductive parts on the same plant, or in some cases it can move from one to the other. And in blueberries, as we'll see later, some varieties can do fairly well in terms of pollination with their own pollen. Others need that cross-pollination, so you might have 2 different cultivars in a field to make sure that that happens. And it's the bees that move this pollen around. Blueberry pollen is rather heavy. It just falls in the air. It's also held, as we'll see, fairly closely in the flower. So unless you get bees visiting your flowers, you don't get the pollen moved and you don't get pollination. Kinds of bees that do this, we'll talk about each of these groups. The bottom left is the honeybee, which many people are familiar with, and we'll spend some time on them first. In the top left is bumblebees, and those in our part of the world where blueberry is native to, the bumblebees are one of the major groups of native pollinators that have evolved over many years to be adapted to work this flower. And then on the right, we've got a photograph of one of the native wild bee species that is in and around our farms and visits and moves pollen and helps the crop get pollinated. Each of these bees has slightly different qualities. Some are very abundant, such as honeybees. Some are very efficient, such as the bumblebees, and some of them can be free, such as many of the wild bees. So we'll talk about that as we go through the presentation. But I just wanted to get everyone oriented to what the blueberry flower is all about, since that's what we're talking about, pollinating. Here you can see the cutaway of a blueberry flower with the central part being the stigma with the sticky end to it at the bottom, and that's connected to the ovary that's at the top, which right now as a flower is not swollen. And then the male parts there are orange. They're dangling down and have a very fine pore at the end, as shown here with these excellent scanning electron micrographs from Patricio Brevis. And he took photographs of these with the pollen that's just shaken out of the end. So you can imagine this like a salt shaker. If you shake it once, you get a little bit of pollen. In this case, pollen. In a salt shaker, it would be salt. And the flower gradually gives out pollen, so that means that bees keep coming to go to the flower to get the pollen out. The flower also doesn't give up the pollen very easily, and so bumblebees have a specific behavior where they sonicate the flower and they shake it at the right frequency and they get the pollen out. Bumblebees and some of the other wild bees are not so good at that. They hit the anthers with their legs, and they do get some pollen, but not as efficiently as bumblebees. So the bee now gets covered with the pollen, gets moved to the next, they move to the next flower, and when they land, they're likely to stick that pollen onto the stigma. This is a colored image of a stigma with blueberry pollen all over it. Now that's important, but you also need to have compatible pollen, which will germinate, and then the male gametes, the male part of the reproductive system, is now going to move all the way up that stigma. And if they make it all the way to the top, to the ovary, and they're compatible, you get fertilized seeds. So that's really the most important thing to realize. It's not just that you get pollen deposited, but it also has to be compatible, has to get seeds fertilized. You may not have looked inside a blueberry fruit, but if you cut one open, you'll see these tiny little seeds in there. And the ones on the right in that photograph are fully fertilized. They're large, plump, and the ones on the left would be considered as being not mature, not well fertilized. So if you count the number of mature seeds and correlate that to the weight of the fruit, you can see there's a really strong correlation there. You need to get that good pollination, get the pollen deposited, so you get the seeds fertilized, so you get the large berries. This is some older data, but in this new project we're talking about today, we've seen the same pattern. This is in blue crop, where all of our research was done. It's a very common variety around Michigan, also in Oregon, British Columbia, we were able to find fields. And you can see here that if you correlate now, instead of just number of seeds, this is now number of bees in 10-minute samples. As the number of bees goes up, the weight that we can attribute to pollination also goes up. So this is showing up in the fields that we've been sampling, and we're trying to translate this into something that could be useful for a farmer when they're out in their fields during a nice sunny day. During bloom, you could look around 10 bushes for 10 minutes, and if you get more than 25 bees, it looks like you'd be up in that top right part of the graph. If you're getting less than 10, you'd be down more in the British Columbia situation there, where they didn't have as strong a pollinating force, and we saw a slight reduction in the berry size. So trying to get to the right is important, and getting bees there to do that will help get berries set. Now I just focused on Jersey and blue crop. Those are two of the dominant varieties that we have in our region. There's a lot of different blueberry varieties, and they all have slightly different requirements for pollination. One thing we've looked at is the difference between these cultivars for the highbush blueberry, which we grow in Michigan, the northern highbush. And this table shows, let's start on the left, we've got a number of different common cultivars. We've got the average weight when you bag, so that photograph that was in the left on the very early slide. And you can see that the size of berry you're going to get, even with bagging and excluding bees, varies widely between the cultivars. And then you get a certain amount of improvement in weight if you just do self-pollination. That's the same pollen from the same plant. So a lot of them are around 30%. But Duke, you don't get any benefit of that, so you've got to get cross-pollination in this set of data. And then in the Elliott, we actually got quite a good set of berry size increase when we use self-pollen. When bees were allowed to visit, they may be more efficient as well, but you can see that we also having that mixture of pollen that they would have brought in helped to get an even larger size of berries. So I think it speaks to the need for having, in some cases, having more than one cultivar around. You can see in blue crop that didn't make a lot of difference, having the cross-pollination. And that's why that cultivar, partly why that cultivar has done well in large commercial blocks of just the same. But for some of these, it would really help to get some cross-pollination. I don't have time to go over all cultivars today, but I would say speak to the nursery, because they would know the recommendations for compatible cultivars. So just to summarize this section, more bees gets you more pollination, gets you more seeds, gets you more berries, and then those berries are larger, which of course is important for yield. I haven't said too much today about lowbush and rabbit eye blueberries. Those are other kinds of blueberries that are grown commercially. They are much more dependent on cross-pollination. And in highbush blueberry, it depends on the cultivar. I would say that for people thinking about blueberries, if you're maybe curious and you got on the webinar today, one thing that's important to keep in mind is that this is a planning point that should be done early, before you have a large block of a single cultivar and realize it should have had cross-pollination. So planning ahead, if you're planting a new field, keep that pollination piece in mind as you're planning your fields. All right, I want to switch to bees and some of what we've learned from sampling bees across a number of blueberry fields. This is the Michigan data, so this is what I'm most familiar with. But this is 17 blueberry fields that we sampled over a number of years, and you can see the wide variation in the number of honeybees that we see here. And as I showed earlier, the more bees that we had, the greater the size of the berries from pollination. But we also see a wide range in the number of bumblebees and other wild bees that might be out there. So it's just saying that, at least within our industry, which is a large blueberry industry, we have a wide range of stocking, and some growers are really focused on pollination. They have a high number of honeybees. They also do what they can to support wild bees, and they may even bring in bumblebee colonies. And we'll talk about each of those as we go through this. So with honeybees, this is our leading pollinator. We've done some surveys here, and about 90% of our pollination is coming from commercial honeybee colonies. They may be brought in by beekeepers. Some of them are from local growers that keep their own. They can be moved in and out. As you can see in this photograph on the right, they're on pallets, so the beekeeper can bring in a forklift truck and move them in and off, onto and off their flatbed truck. We've seen a little bit of an increase here in the rental fee, but nothing like has been reported in California. So growers are still investing in honeybees, and but also interested in alternatives to maybe diversify where they're getting their pollination from. When we give recommendations about stocking densities, this is the most complete set of recommendations that is published that I know about. Maybe someone on the call knows of a more recent one, but this is from 1992, so it goes back a way, but it makes the point that some cultivars are much more dependent on or much more attractive than others, and they also can do well with lower stocking densities. Others, you've really got to push the honeybees in there to make sure they get pollinated. So you see a range, a five-fold range among different cultivars there in terms of the recommended stocking density. I did also want to mention that some of the farmers we work with are really keen to get pollination every year as good as they can get it, and even with the price of honeybees having risen a little bit, they still are investing more in honeybees to make sure that they don't lose out when there's a couple of good days of weather in the spring, and they really want to make sure all their flowers get visited. So there's a little bit of a disconnection between some of the older recommendations and some current practices, but I would say in general people are stocking here at 1 to 2 colonies per acre, with some outliers to that. Often we recommend that honeybees don't get brought in until the crop starts blooming, because otherwise the honeybees might go off and start foraging on something else. Spread them through the farm. It helps to get some early morning sun if you can set them up that way. And then something to think about is your hive strength. It's not just how many boxes you have, but how many healthy and strong boxes you have. And so there's some guidance here on the kinds of things to think about in terms of planning for getting, for getting your honeybees. We can get colonies that come up from Florida and Georgia that have been in the south for the winter, and so those tend to be a lot stronger than those that stay in the north. They're already built up, and they may also have gone to California already for almond pollination. Something you can do as a grower is to talk with your beekeeper about a contract. Many times this is just done by a handshake and an agreement, verbal agreement, but there are written contracts that can be used, and I've got a link here. When you get the slides, you can just click on that link and it will take you to an example contract that you could adapt for your own needs. So just to summarize, honeybees are a really central part of commercial blueberry pollination. Varying the stocking around your farm based on your cultivar is recommended. And I've made the point there about flower density. That may be part of what's happening with the older recommendations, where increasingly growers have been pushing the number of pounds per acre they're getting from their fields. And so that means more flowers, which means you need more pollination. And so it may be worthwhile playing with a slightly higher stocking density to see if that gets you greater yield. And then the last point there, working with your beekeeper to get strong hives. I think many growers have good relationships, good history with their beekeepers, and having a look at those colonies as they come in and making sure, as you look around the ones you've rented, that they're all strong, can really help you make sure you get good pollination from your honeybees. All right, we promised that we would give you a little break and a chance, if Katarina is checking the Q&A and the chat, if there's a couple of key questions that we want to get done here, then we can move on with the rest of the slides.
Yeah, I'll pull out 2 questions right now. There's a couple of other ones, but we'll get to them a little bit later. So Peyton asks, in relation to blueberry pollination, does this increase in yield per plant, or is there some limit to the weight of berries that might be carried by a plant? For example, do you get fewer but bigger berries?
Yeah, that's a good question. If there's a compensation there between berry size and number of berries. I haven't studied that, and I don't know off the top of my head of any study that looked at that, but what I have seen is some fields where in some years we have had sort of fluctuations where one winter we might get a lot of winter injury. The next year the wood is growing back, and if we get a really, really high level of pollination and really high yield, then the bushes might be less able to hold a good yield the next year. So I haven't seen it in berry size during the year. Maybe others have got some thoughts on that, but I have seen young bushes where it almost looked like they were over-cropped one year as they were getting mature. Maybe once the bushes are really big and can handle a larger yield, that's possible, but it's a good question.
So I think for the sake of time, I'm going to ask one other question now, and we'll save more towards the end.
Okay.
So one other question right now is, I guess we can combine 2 questions here. One is, are certain cultivars more attractive to bees than other cultivars? And sort of related to that, we have one person asking about your opinion on beekeepers supplementing syrup to bees while pollinating blueberries.
Okay. So on the syrup, I haven't got a clue about that. I really don't know much about the beekeeping side of things to answer that. So I'm not sure, but I would say in answer to the first question that there are definitely variations in attractiveness. If you look at the table, when you go back to the slides, there was one that was ruble, which was one of the varieties that needed only half a colony per acre. And in our research planting, we've had Jersey right next to ruble side by side, and the honeybees will all be over in the ruble, and it's a very attractive variety. And I think that's part of why you don't need such a high stocking density in that one. So yeah, that varies, but also flower morphology varies, and that can influence whether or not honeybees are able to work the flower really well. There's some nice work by my colleague Elizabeth Ellie from British Columbia, and you can look for her work online and see some of the differences between the cultivars there.
Great, and just to follow up on that syrup question, the person was asking specifically about competition between the syrup and bees visiting the blueberries. because blueberries don't produce nectar. And just for everyone on the call, Ron had a comment for that in the chat box, so you can check it out.
Okay. Yeah, so let's keep going, because I know there's more slides and we can get to the questions at the end. Okay, so this photograph was selected because it depicts what often happens during our blueberry season, where in the spring, where we have this field on the left is starting to bloom. It's got flowers in there, but this is actually midday or 1 o'clock in the afternoon and a misty, cool spring day. And so those honeybees are there. They've been purchased, rented, been placed there, but they're not pollinating because the honeybees don't want to come out during that gray, cold weather. So it brings us to think about other bees and how we might diversify the pollination force by thinking about other pollinators. So in Michigan, we have a number of species. There's probably 10 that are alternative wild pollinators that could visit blueberry fields. And we can think of those as pollination insurance, something that can spread the risk that you don't get pollination. We're trying to avoid that at all costs, given all the investment you've had in bushes and land and all the other things that it takes to grow blueberries. Some of these species are extremely efficient. The bumblebee on the left there is, as I said earlier, very well adapted to blueberry pollination, so they're very good at getting that pollen out, taking it on their body, and moving to the next flower. They're adapted to this weather. They've seen it all before, so this is a group of insects that are more likely to fly when it's cooler. Not to say that they won't be affected to some extent, but they're more likely you're more likely to see bumblebees out foraging during the cooler spring weather conditions. And they're free, some of them. So if it's wild bees, you're getting that from the wild areas in and around your farm. Just to go back to that point about relative efficiency, these are some numbers where you can look and see that on average a honeybee is depositing about 11 pollen grains per visit. It's about 4 times higher for the other bees. Some of them, the bumblebees, visit more flowers per unit time, so you can watch them and see that they're very efficient going from flower to flower. So there's about a 6-fold improvement in the number of flowers pollinated per minute when you compare honeybees and bumblebees. Of course, honeybees are there in the tens of thousands, and that's their big advantage that the other insects don't have. But still, the combination could give you efficiency when it's cooler and abundance when it's warmer. We've looked at bumblebees because this is a commercial crop, commercial pollinator. In our region of the world, we can purchase Bombus impatiens, the common eastern bumblebee. Other parts of the world have other bumblebees that they can use. They are actually produced in a sort of indoor environment, and then you get a box like the one in the bottom right that has 4 colonies. There's 4 little holes there, and those 4 separate colonies have a queen and about 200 workers that can come out to pollinate. We've done some comparisons to look at fields. This study was looking at fields that had only bumblebees as much as we could. Of course, the wild bees still come in, but only bumblebees or only honeybees. And if you look at the number of bees per 10-minute sample over 2 years, when we had just bumblebees, then we got a bigger green segment, as you might expect. When we had only honeybees, we got a bigger yellow segment, as you might also expect. But we can adjust for those efficiencies that I just talked about and see that there was somewhat equivalent levels of pollination effort that we would expect from seeing that many bees of those kinds on these flowers. So then the question is, well, what did that mean for yield? The measure we have here is like how much increase in yield do you get when you have these different treatments. And over the 2 years, the honeybees were a little bit higher. Of course, it was honeybees and some wild bees and a few bumblebees. The ones that were stocked with mostly bumblebees still got pollination, but were just a little bit lower. So I think it says that bumblebees can pollinate, and that maybe we needed a few more colonies per acre to get the effect, to be equivalent. We've also looked more recently in this integrated crop pollination project at comparing fields where there's blue crop variety fields with just honeybees, and then those that were compared were honeybees with bumblebees on top to see if we get that additional pollination yield. pollination and yield. And in this set of data, you can see the light blue is the honeybees only. In the interior of the field in the first year, 2014, we saw a slightly higher yield per hectare that's calculated from these fields, but not a consistent and not a significant difference across those situations. And of course, this is an additional expense. And in this setting, with the honeybees there already at a good stocking density, we got good pollination. It's possible that with a different cultivar, a colder spring, if we put more of them in there, we would have got a better situation. And in this case, we had 2 years where there was some winter injury the year before, so we also didn't have a full complement of flowers. So those are the data, and at least for the setting we did this in, we didn't see the additional bump from adding bumblebees. So to summarize some of this, the alternative bee species are excellent blueberry pollinators. They have the methods for moving the pollen very efficiently. You need a high density of them to get a measurable effect. And at least in our setting, we didn't see that additional benefit in the blue crop fields. What a lot of growers have moved towards is a combined strategy where they're trying to think about how can I get my honeybees in reliably from the beekeeper? How can I, maybe in some of my harder to pollinate cultivars particularly, I'll put my bumblebees there and see if we can boost the pollination. And then I'm going to do what I can to increase the number of wild bees around my farm, because I know that those are going to be here on those situations where maybe the other pollinators can't provide the service. And also, in some cases, there's not from blueberry, but some other studies shown that they help the honeybees and the bumblebees do a better job. So we're going to switch to talking about wild bees for a few minutes. And this is one of our native species that lives in the ground. It lives in the soil for its nest and then comes out and pollinates blueberry flowers and then returns with blueberry pollen to feed its young in that nest. And this is one of our more dominant species that provides a good part of our pollination, especially in smaller fields where there's a lot of wild habitat around them. We have a great diversity of wild bee species here, again, with blueberry being native to this area, and here for so long we see a number of species that are adapted well to these flowers. Their abundance tends to be affected largely by what happens around the field. So this is some data showing the proportion of semi-natural area in the bottom of the graph. And so as we go from 30% all the way up to 70%, you see about a doubling of the number of bumblebees and other wild bees. So you can think about your own field setting. If you've got a lot of wild land around, you're more likely to get these wild bees than if you're surrounded by maybe urban areas or more agriculture. So this is one general trend that we've seen. Part of that is because they have nesting sites, but another part of that is because they have access to pollen sources, and the pollen helps them in many aspects of their health. And so we've been thinking about how do we get these resources back into farms. Not every farm has the capacity to change the landscape around it. So one other approach is to take more of a local approach and plant some of these pollinator supportive plants. This is one example from a farm we've worked at where the blueberries are in the background. And this area that the farmer was just mowing every year is now planted to a pollinator planting. We're trying to boost the local wild bees populations so that when that blueberry field is in bloom, they can go in there and help get pollination. This is another example from one of the other fields we've worked in. And a student here, Brett Blau, has done some work to track this over time. He looked at 4 years after the habitat was established and saw a significant increase in the number of native bees visiting the crop flowers. These are fields that had honeybees in them, but in addition, we got more wild bees. We also got more of the natural enemies that can also help pollinate. They don't pollinate blueberry very well, but they do help pollinate some other plants and are good at killing aphids, so they're getting some biological control there. In these fields that either did or did not have the habitat, we also looked at yield. And this graph here shows the comparison of yield per hectare. That's the kilograms per hectare is about equivalent to pounds per acre if you're trying to adjust those numbers in your head. And so there was a slight boost of pollination when there was the flower planting next to the field. And this was some work we did a couple of years ago now, but it's interesting to see also a recent study out of Maine from one of my colleagues in his lab has shown a similar kind of response in low-bush blueberry, where they were able to show a yield boost over time as the wild bees were able to increase their populations locally. So summarizing here, farms have multiple wild bee species. Wherever you are, there will be some wild bees that are there, and some of them are, hopefully for you, excellent blueberry pollinators. They're going to need nesting habitat and maybe some plant cavities for them to nest in, depending on the species. And they'll all need, most of them will need some flowers outside the time when your blueberry flowers are in bloom. So trying to think about resources that can be enhanced in the farm. In our part of the world, there's some cost share programs from the Farm Service Agency and the NRCS. So if you're in the US, you can ask at that local office and they might be able to help you with some of the expenses for this. The last section of this talk is about trying to protect your pollinators. Obviously, if we are growing a crop that needs pollination and we need bees to do the pollination, and whether they're your native bees that are on the farm or bees that are being brought in by a beekeeper, we need to keep them healthy and alive through the season. Some of them are active through the whole year and some of them are just active during bloom, but it's worth thinking about the pesticide safety issues during the whole season. We have a number of insect pests that growers need to manage from before bloom all the way through to the end of harvest. And so keeping in mind the pollinator risk as we go through the season, whether it's insecticides or increasingly people are concerned about fungicides, that's an important consideration to make sure that bees are healthy. This image shows some of the different places and ways that bees can pick up pesticide residue. It's not just direct application that could get them, but there could be drift, there could be pesticide going into the soil where they're nesting or onto alternative foraging plants. So something to keep in mind as you're trying to protect the pollinators in your farm. The other thing is that there's a lot of different levels of toxicity of these pesticides. Some of them are restricted and cannot be used during bloom, and those will be the ones that are the most toxic to bees. But as you go down this list, you can see that the LD50, which is the amount that will kill 50% of the bees, increases. So that means they're more and more safe as you go down the list. So growers do have some options, whether you're talking about in bloom or later in the season, in terms of bee risk from pesticides. And one resource that I'll point out to everybody down in the bottom right here, there's a resource that the University of California IPM programs put together. And if you click on that link when you get the slides, it'll take you to a page where you can select any of the insecticides, fungicides, herbicides, and it'll give you some details on their bee toxicity. Of course, the pesticide label also has a lot of information, and those are being updated in the United States based on some of the concern about pollinator risk. We've studied the relationship between insecticide use and wild bees in the blueberry farms we've been working in, and you can see here, as you increase the overall hazard of the pesticides used for bees, you get a reduction in this is the number of species of wild bees, but you also see a reduction in their abundance and diversity. And so I totally understand that growers need to manage their insect pests, but if you can think about trying to select products that are less toxic to bees, then you'll move your farm more to the left, have more wild bees, and help improve the chance that they can support your pollination. We have I'll show you the link to this later, but there is a guide that you can read which has a lot more detail on this and some of the tactics that you could use for trying to minimize pesticide risk to bees. So just summarize this section by emphasizing that we understand that growers need pest control. They also need their pollinators, and trying to find that balance is, I think, the important thing to focus on. Using IPM tactics where they're available, and least toxic options can help. And then avoiding contact is a big part of this. So if you can make applications at night, when bees wouldn't be foraging, if you can make applications that don't drift onto adjacent flowering habitats. All of these pieces of the puzzle can help reduce the pesticide risk to bees. And I mentioned this just now, but the label directions are important to keep in mind. If you look on the labels in the United States, the label is the law, and increasingly there's this bee hazard section which can be identified really clearly by this little icon, and you can see in there the restrictions that are placed on pesticide use to protect pollinators. Okay, well, my last slide here of detailed information is to say that we, I think, have seen today that blueberries require pollination for good yields. For honeybees, it's important to adjust your densities based on cultivar and expected yield. The expected yield part I didn't focus on earlier, but obviously if you have a young field where there's only 1 foot high bushes, they're not going to need as much as a 6 foot high bush. So that could be another point of adjustment. Think about these bumblebee colonies for the hard to pollinate cultivars and for poor weather conditions. Part of how you can support whether it's honeybees or wild bees is to provide habitat and also to reduce pesticide risk. And we've given you some guidance on that today. And I think there's a last point, which is something that we're moving into more in our research next year, or this year, which is to develop tactics that people can use to monitor their pollination each year. And doing that yourself and learning from your experience, I think you can learn a lot about how to optimize pollination for your own crop, your own fields, your own farm. So I mentioned this blueberry work is a collaboration. There's 4 names down at the bottom from the 4 institutions. And I've got a bit of a Michigan focus because that's where I've done the research and that's where we're coming from on this webinar today. But if you have questions, I'd encourage you to, and you're in one of these other areas that's highlighted here, I'd encourage you to talk to my colleagues on this project. And I'm sure you can find the links online for them. Okay, I wanted to leave you with a few resources. Again, when you get the PDF of this presentation, you'll be able to click on each of these links and on the images on the right, and it will take you to those. The fact sheets, the 3 fact sheets that are shown there are free, and it will take you straight to a PDF. You have to buy the bee guide if you're interested in that from this region. And then the ICP website has a number of videos and a lot more than that that you can dig into if you go to our project website. I also wanted to take a chance, if you're in the United States, to highlight the Ask an Expert resource. So eXtension, that this webinar is being hosted by, they have this Ask an Expert facility, and if you get in there, if you can find that online, and again, you can click on that box and you'll get straight there. You can ask a question and it will automatically go to someone from the Extension service in your area. So that will help get more local recommendations for you. Okay, and the last slide, I don't know if Katarina wants to talk about this or if you want me to do it, Katarina?
You can do it, that's fine.
Okay, so as was mentioned at the beginning of the webinar, we have a series of these webinars coming out this spring, and the next one will be on February the 14th. It's on apples and cherries in the eastern US, and you can register for that by clicking that box once you get the slides. There's a whole list of these events at that link that's down in the bottom right, and whether you're interested in crop production or the business side of agriculture or pollination, as in this case, there's something for everyone in there. And one that we wanted to highlight that's coming up on February the 7th is one for organic growers and focusing on providing habitat for wild bees. And I expect that the recommendations that are coming in that will be relevant to commercial, conventional growers as well. So think about registering for that one on February the 7th. Okay, I think we've got some time left. I tried to bust through the slides so we'd have plenty of time for questions. So thanks for your attention.
Great, thanks so much, Rufus. So we have a number of questions in the Q&A box, and I'm guessing a couple of more will come in as we take time to answer questions in the next 10 minutes. So there are a couple of questions related to pollinators of blueberries. So one question is, are hummingbirds effective pollinators? So when I see them as a visitor, are they effective pollinators?
Okay. Yeah, so I don't think honeybees, I don't think hummingbirds would be a good pollinator of blueberry. One thing about that, the male part of the flower, is it really needs to be vibrated at the right frequency to get pollen out. So I wouldn't expect that a hummingbird would get a whole lot of pollen. And there's a lot of flowers to visit. We've counted something like, depends on the field, but 5 to 6 million flowers per acre in a mature blueberry field. And I'm actually really amazed. It's a very cool observation, but I'm amazed that a hummingbird would go there, just because you wouldn't think there'd be a lot of nectar in there for a hummingbird to collect. But I've never seen it. I would love to see that. If you could put in the chat box where you're from, that would be really amazing to see.
I've never seen them on blueberries on either low bush or on rabbit eye.
I'm going to move to the next question just in the interest of time. Would an excess of bees cause damage to blueberry flowers?
Okay, so we didn't talk about one of the dark underbellies of the bee world today, which is carpenter bees. And carpenter bees can damage blueberry flowers. They will actually cut a slit in the petals because they don't want to go in through the business end of the flower, and they go in around the back, and they will cut holes, and then honeybees will learn that hole, and that does mean that they're not pollinating the flower. But I've never seen honeybees cause that damage directly, and I've never seen any other wild bees cause that damage directly. So I think really carpenter bees will be the ones that might be of concern. In our area, I don't know which part of the world that person's in, but in our area, carpenter bees are typically active as blueberry bloom is tailing off. So most of the pollination has already been done, but they will come in sort of on the last 25% of the blueberry pollination season.
With rabbit eyes in the south, we have the same scenario, but research done by Jim Kane and others has shown that it doesn't affect yield, which even though they perforate, you think they cause damage, but it doesn't affect the yield, and the fruit still develops.
Oh, thanks, John.
Sure.
So another question is from a farmer who has a 3rd acre of blueberries of various varieties. They said last year honeybees were almost completely absent. The wild bee population seemed inadequate. Our later blueberries lacked pollination. We had been planning to bring in bumblebees this year. Should we go with the bumblebees, or should we try to get honeybees? I'm not sure what part of the world they're in.
Yeah, so I think it depends on what's what's available locally, but I would probably suggest doing both. I think that's the way that you're going to be able to capitalize on really good sunny weather days. Those honeybees will be boiling out of the colonies if they're nice strong colonies. And then if you've got some variety, it sounds like you've got a lot of different varieties there, and if they happen to be open during days when it's cool and less likely to have honeybees flying, then that's when some bumblebees. I think another thing to think about is, obviously you're concerned about next season or this coming season, but trying to think as well about like long-term strategies to build up the wild bees in the farm is another thing to be thinking about. There's some maybe some simple things that could be done that you're not going to change it all next year, but over the next, say, 10 years, if you're growing blueberries, you're thinking long-term. So that can be part of the long-term plan.
Great. So in the interest of time, we're going to only ask 2 more questions live. For people that have asked questions that we don't get to, we'll respond to them after the webinar and send them out to everyone along with the slides. So if you have more questions, go ahead and add them. These next 2 questions are more on the farm management side of things. So one person was asking, in terms of those wildflower plantings that you showed, how did you guys design the seed mixes? How did you decide what plants to put in there?
Yeah, thanks. So I took that slide out for time, so I'm glad you asked me the question so I can get back to it. So we've done some work in this region where we've tested individual native plant species in a replicated experimental design, found which ones are most attractive to bees, combine those into a mix where there's bloom that starts after blueberries finish blooming and then carry through the rest of the season, with the idea that a bumblebee that's starting to emerge during blueberry flowering, that colony that it's from is going to need resources through the rest of the summer. So we've designed a mix that provides that season-long combination of species to provide those resources. We're continuing to update that list. We're looking at some species now, plant species that will do well in dry soils, and so we're hoping to expand that palette. If you're really interested, we have a website, nativeplants.msu.edu, that can provide a bit more detail. Or, like I said, there's an email address on the front of the slides, and you can send me a message. I also provided a link in the slide to the Xerces Society website, and they have regional specific mixes listed in there, so you could look at something that's been selected from your region based on experience.
Great, thanks, Rufus. Another management question is related to fungicides. We have someone asking, how much do we know about the impacts of fungicides on pollinator health? Are there fungicides we should not be using during bloom?
Yeah, good question. So I think the fungicides question has come up increasingly. People are studying that now, and there are I don't have a direct experience of doing this research in blueberry, but I know that there are folks that have been studying the risk of fungicides. Primarily, what they're learning now is that that will disrupt the microorganisms that are helping the bee degrade the pollen for their larvae. And so that's one mechanism that they might be affecting honeybees. So I don't have a particular product to give you a thumbs up or thumbs down on today, but that guide that I talked about earlier does have a list of fungicides in it. And additionally, recently they've also been looking at some of the effects of some of the adjuvants, things like the organosilicone adjuvants that go into some of the spray tanks, and showing that those can also affect bees by synergizing some of the effects of viruses. So I think there may be other people on the call that have more experience of that than I do, but I would say talk to the local extension service and your local researchers that maybe have some more experience on fungicide effects on bees.
And actually, I'm going to throw in one more question just because a couple of different people have asked this in the Q&A box, and that is there any way to make blueberry flowers more attractive to bees, a way to get bees to blueberry flowers?
Well, we have actually done a little bit of research on an attractant that we hoped would do that. It was a chemical that was supposed to be attractive to honeybees, and we did some tests spraying that into blueberry fields. It actually didn't work. They seem to still be able to go and find the plants that they want to be on. So I know that there have been recommendations where people talk about trying to mow off the dandelions, so they're not going to the dandelions and they're going to blueberry flowers, but it's not the most rewarding flower out there often in the landscape. So that gets back to the need to move the honeybee colonies and spread them in your farm to help them get to the flowers more near to the colonies that they otherwise might not visit.
Great. So with that, just because we're almost hitting the end of the webinar here, the rest of the questions, and there's a number that we aren't going to be able to get to, we'll respond to those by email. But if you have something you desperately want answered, go ahead and put it in the Q&A box, and we'll send that out with the email at the end of the webinar series. I'll pass it over to John to wrap things up, and we'll be sending out, we'll be posting a poll right now. In addition to, I'll be posting the CCA credit form that you can fill out in the chat box. Oh, and thank you so much, Rufus. But I'm sure John's going to talk about that too.
You're welcome.
Yeah, thank you, Katharina. And thank you, Rufus. And thank you, Mark, for participating in this webinar. As you go through the quick poll, please remember we are going to have additional webinars in this one and in other series. Please check the Bee Health e-extension website where you can find out more about this, and also the extension Learn that Mark put up in the chat box earlier. I certainly appreciate you and your expertise, Rufus, and your knowledge of highbush blueberry. It's an important crop, and with this kind of participation, I thank all the participants for attending.
Yeah.
I know I learned some things, and I really hope you did too. So please don't forget our future webinars that we're going to have. One on the 14th of February, Pollinating Apples and Cherries East of the Rockies. So another exciting webinar to ensure better pollination. Thank you very much. Anybody else have any other closing comments?
I'll just add quickly, because a number of people are asking about it, and Rufus, I think, alluded to it during his talk. I think the presentation will be available in PDF form, and we'll send it out to registrants in the next couple of days. Rufus, is that right?
Yeah, that's right.
Yeah. So you should all be able to get access to the PDF, and in addition to that, we'll have answered the Q&As or the questions that come into the question and answer box too, and we'll send those answers out with that email. I think that's everything then. Great, thanks so much, Rufus.
Yeah, thank you, Katerina. Thank you, John. That was great.
Thank you.
Thanks everyone.
Super, and thanks everyone for coming today.
Okay, thanks everyone. Bye-bye.
Thank you, and bye.